Hello student, once again welcome you all. Myself Samadhan Patil from JIT Engineering College Nasik. So today we are going to discuss about the next unit is vector integration, and the very first concept it is important, and it is a line integral. Actually it is important for all the branches, and only there are four concepts in this unit. First is a line integral, second is a Green's theorem, third is a Stokes theorem, and then after that uh, divergence theorem. Okay, so we will discuss them one by one. Okay, so let us start the line integral. Okay, as we have seen the vector differentiation, many of the basic concept we just follow from that first that previous unit, vector differentiation. Okay, before starting the actual topics, so let me introduce one more thing for you. So for more information about M1, M2 and M3, so just follow me on my blog. So that link I have now providing you. So http samadhanpatil17.wordpress.com. So why this is useful for you? Because it it contains, I have uploaded the syllabus of engineering mathematics 1, 2 and 3. Okay, from that I have uh, uploaded on my blog. Okay, then second is unit wide notes for engineering mathematics 1, 2 and 3. So M1 and M2 are common for all branches, but the M3, so branch wise I have uploaded the notes, syllabus, all that things on my blog. Okay, then assignments for practice also there, university and question papers are also there. Then MCQs for practice, this is very important. Okay, because all the unit wise MCQs already I have uploaded, so you just follow the blog so that you can find out all that things and take a help of all that uh, material for your study. Okay, now let us see what is by line integral and what is the formula to calculate the line integral. Okay, so we use this formula to calculate the line integral. Some examples are there. Okay, so let us see the line integral. An integral which is evaluated along the curve is called as a line integral. So whatever the curve we have, so if we have the curve, suppose if we have the curve. Okay, so suppose this is curve, and now so whatever the integral along this curve, evaluated along this curve, so it is called as what? Line integral. So we just see the formula for that. So a line integral is f bar dot dr bar. So what is f bar? It is a vector point function we have seen in previous unit. And dr bar also we know, r bar is xi plus yj plus zk, dr bar is dxi plus dyj plus dzk. Suppose if where c is a given curve, so this is c. Okay, so this is c, given curve. Now suppose if f bar is equal to f1i plus f2j plus f3k, and dr bar is dxi plus dyj plus dzk. So the dot product between f bar and dr bar, so what is that? So it is f1 dx plus f2 dy plus f3 dz. So therefore integration f1 dx plus f2 dy plus f3 dz, and this is what? This is a line integral. Now also work done by the force field f bar in a moving particle along c, curve c from a to b is given by. So this same result we use to calculate the work done also. Okay, so what is that result? So this is work done is equal to f bar dot dr bar from the point a to b. So work done by the force field in a moving particle along the curve c is given by what? It is integration a to b f bar dot dr bar. F bar dot dr bar is nothing but same, f1 dx plus f2 dy plus f3 dz. Okay, let us see the first example. So example is, find the total work done in moving particle by the force field. So this is the force field f bar is given, that is 3xyi minus 5zj plus 10xk along the curve x is equal to t square plus 1, y equal to 2t square, and z is equal to t cube from t is equal to 1 to t is equal to 2. Okay, so work done means same, line integral f bar dot, we have to find the line integral along the curve. Okay, along the curve, what x is equal to t square plus 1, y equal to 2t square, and z is equal to t cube. and from what t is equal to 1 to t is equal to 2. Okay, so we have the formula, work done is equal to integral, so f bar dot dr bar. So this is the formula. F bar is means f bar, f1i plus f2j plus f3k, and dr bar is dxi plus dyj plus dzk. So simply this is f1 dx plus f2 dy plus f3 dz. Now put the values of f1, f2, f3. Okay, so now see, this is your f1, so this is your f1, this is your f2 minus 5z, and 10x is the f3. Okay, so you just put that values here. So 3xy, this is f1. Okay, so this is your f1, this is your f2, and this is your f3, 10x. Okay, now call this as 1. And now what we have to do, we have to either convert the what in terms of x, y, in terms of single x or single y or single z, or otherwise we have to find another variable so that we can express each variable in xyz in terms of that another variable. So fortunately here we have the curve, is it we have the curve x is equal to t square plus 1, y is equal to 2t square, and z is equal to t cube. So values of xyz are in terms of t. Okay, and also limits of t are given. So here what we are going to do here, so we are converting this total integral in terms of t. Okay, so because we have the values of x, y, z, so only problem is what is dx, what is dy, and what is dz, because the limits of t are also given. So t from 1 to 2, t is equal to 2. So we just only find the values of dx, dy, and dz, and it is very easy from this value. So x is equal to t square plus 1 here, so therefore dx is equal to 2t dt. Am I right? So what is dy? Y is 2t square, and therefore dy is nothing but 4t dt, and z is nothing but t cube, therefore dz is nothing but 3t square dt. And from t run from what, t run from 1 to 2. Getting this? Okay, so we use all this value in equation number 1. Therefore equation 1 becomes what, see here, so this is 3xy dx minus 5z dy plus 10x dz. So 3 as it is, x is t square plus 1, y is 2t square. Okay, and dx is nothing but 2t dt, that we have seen in a previous step. Okay, minus as it is, 5 is as it is, z is nothing but t cube, and dy is nothing but 4t dt, and 10 as it is. Okay, x is nothing but t square plus 1, and dz is 3t square dt. Got it? We have just replaced here the values of x, y, z, and dx, dy, dz. That's it. That values we have now in the previous step. Okay, now just solve this, and if we solve that, what I get, integration from 1 to 2. So 3t square, see here, 3t square, 3 into 2 is what, 6 into 2 is what, 12, and t into t square, t cube into t square is t raised to 5, 10 t raised to 5, and 2 into 2 is 4, 4 into 3 is 12. Okay, and t square into t is t cube, into 1 is 12 t cube, like this. Okay, so that all dt's we take outside the bracket from all three steps. Okay, now here 4 into 5, it is minus 20. Okay, so this is minus 20 t raised to 4. Then after that uh, t square, 10 t square plus 1 means 3t square, 10 t square into 3t square is what is it, 30, 10 into 3 is 30. Okay, and t square into t square is t raised to 4, 10 into 1 is 10, into 3 is 30, 30 t square dt. Got it? Okay, now 12 t raised to 5 plus 12 t cube plus 50 t raised to 4, and plus 30 minus 20 plus 30 is plus 10 t raised to 4 plus 30 t square dt. Okay, now so here it is 12 t raised to 6 plus 6 by 6 plus 12 t raised to 4 upon 4 plus 50 t raised to 5, their integration. So 12 as it is, integration of t raised to 5 is t raised to 6 upon 6, plus 12 as it is, t raised to 4 upon 4, my plus 10 as it is, t raised to 5 upon 5, integration of t raised to 4, and plus 30 as it is, t cube upon 3, from 1 to 2. And so if we apply all the limits, what I get, we get the answer 303. Okay, so apply the upper limit minus lower limit, so whatever the answer, that will be your final. Okay, so it is 303. I think you can put that values. So with the help of calci you can already know 2 raised to 6, 2 raised to 4. Okay, and just replace all that values, we'll get what? You will get the answer 303. Got it? Okay, so this is the first example of line integral. Let us see some more examples. Now the next question is evaluate this line integral f bar dot dr bar. F bar dot integration f bar dot dr bar means line integral. So now f bar is given 3x square minus 6yz I plus 2y plus 3xzj plus 1 minus 4xyz square k along the line joining 0 0 0 to 1 2 3. Now here values of xyz are not in terms of t, but to find that we have the straight line from 0 0 0 to 1 2 3. So we can use here 2-point form so that we get the values of xyz in terms of t. Either the values are directly given in terms of t, or the line is given joining the same points, joining the 2 points, isn't it? Okay, so let us see the solution. Same here we have the line integral f bar dot dr bar over c. Now f1 dx plus f2 dy plus f3 dz over c. Put the values of f1 f2 f3 here. So this is your f1, this is your f2, this is your f3. Okay, so now we have just take their values. So this is your f1, this is your f2, and this is your f3. Okay, call this as one. So here we just use the 2-point form for this. So what is 2-point form? X minus x1 upon x2 minus x1. Okay, same y minus equal to y minus y1 upon y2 minus y1. Okay, divided by y2 minus y1, and same this is equal to what? Z minus z1 upon z2 minus z1, and using that we get this equation. See, x minus 0 here, this is x minus 0 upon x2 means 1, this is x2, this is x1 y1 z1, and this is x2, okay, y2 and z2. This is x2 x1 y1 z1, and this is your x2 y2 z2. So x minus 0 upon 1 minus 0, like this. Okay, so therefore it is x upon 1. Similarly y upon 2 equal to z upon 3, and all these ratios equal to t, say. Okay, so therefore if you consider x upon 1 equal to t, what I get? X is equal to t. Y equal to y upon 2 is equal to t means y is equal to 2t, z is equal to 3t. So therefore if we take the derivative, what is the derivative of dx dx t dt? Dy is equal to 2 dt, dz is equal to 3 dt. And if you see, if you find the limits here, so it is uh, once again interesting part. So see, what is the lower limit of x? 0. Lower limit of x is 0. So if you take x is equal to 0 here, what I get? T is also 0. Okay, so therefore t is also 0. So what is the upper limit of x? It is 1. See here, it is 1. Okay, and therefore if I take 1 here, what I get? T is equal to 1. So in every value, so we'll get the same limit. For example, see, if I take y equal to 0, so t is 0. If I take if I take y equal to 0 here, see, this is a lower limit of y is 0, so t is equal to 0. Upper limit of y is 2, so if I take y equal to 2, 2 upon 2 is 1, t is equal to 1. So same here we get 0 to 1, and for same z is equal to 3t we'll get the same limits. Okay, so now use all these things in equation number. What I get? So equation 1 becomes here, see, integration 3x square minus 6yz dx plus 3y plus 3xz dy plus 1 minus 4xyz square dz. Put all the values. Okay, 3t square, x is nothing but t, 3t square, 6 as it is, y is nothing but 2t, z is nothing but 3t, dx is nothing but dt. Okay, 2 as it is, y is nothing but 2t, 3 as it is, x is nothing but t, z is nothing but 3t, and dy is nothing but 2dt. And here 1 as it is, minus 4 as it is, x is nothing but t, y is nothing but 2t, and z is nothing but 3t, its square, because z square is there, and dz is nothing but what? Dz is nothing but your 3dt. Okay, so dz is nothing but 3dt. Now what I get here, see, 3t square as it is. So if we calculate all this thing, what I get? So 3t square minus 36t square. 6 into 2 is 12, 12 into 3 is 36, t into t is t square. 2 into 2 4, and 4 into this 2 is 8, because this 2 is multiple with this bracket. 2 into 2 2 into 4 is 8. Okay, 8t plus 3 into 3 9, 9 into 2 18, t into d t square. Okay, plus 3 is there. This 3 into 1 is 3, and 4 into 2 8, 8 into 3 square 9. Okay, 4 into 2 8, 8 into 2 72, 72 into 3 minus 216, minus as it is, t into t square into t square is t raised to 4. Okay, just evaluate this now. To 3t square plus 18t square minus 30t square, that is minus 15t square. So I just merge these three terms, all the terms of t square. So this one and this one, I get minus 15t square plus 8t as it is, plus 3 also as it is, minus this term as it is. So if we integrate this, minus 15 as it is, okay, and integration of t square is t cube upon 3, integration of t is t square upon 2, integration of 1, this is 1 here, it is t, 3 as it is. Okay, and integration of t raised to 4 is t raised to 5 upon 5 minus 216 as it is from 0 to 1. And now if we apply the limits, what I get, minus 15 upon 3 is minus 5, so upper limit is 1, t 1 raised to 3 is 1, so 1 is there. 8 upon 2 is there. Okay, so 8 upon 2 plus 3 into 1 is there, and minus 216 upon 5 is there. Got it? Okay, and if we solve this, what I get, it is minus 206 by 5. Okay, so this is the answer of this. Okay, you can solve this with the help of calci also, or without calci also. It is very simple. LCM is 5, and multiply by 5 to all this stuff and subtract them, isn't it? Okay, next example 3. Find the total work done in moving particle along the by the force field. F bar is 2x plus y square I plus 3y minus 4xj, and taking the particle around the parabolic arc y is equal to x square from 0 0 to 1 1. Okay, so see, f3 is not there, the term of k is not there. Okay, so this is simplest example. Now same here, we know that work done is f bar dot dr bar f1 dx plus f3 dy plus f2 dy plus f3 dz. Substitute the values of f1 f2 f3. Now f3 is not here, so this term is 0 here. Okay, there is no f3, f3 is 0, so therefore this is 0 here, so this term is not here in the calculation, further calculation. Okay, so therefore this term is 0. So we just put the values of f1 and f2, f1 dx plus f2 dy, called it as equation number 1. So same here, as we have the curve, it is parabola y equal to x square. See, one more thing is here, because we don't have the values of x y in terms of t. Okay, so you can use the 2-point form, but because of 2 points are given, but we are not using that, because the line is not a straight line, the curve is not a straight line actually. If it is a straight line joining 0 0 to 1 1, then we use the 2-point form. Here also we are unable to use that thing, but one more thing is helpful for us here. So it is curve y is equal to x square. We can convert this total integration in equation 1 either in terms of x or in terms of y. Okay, so see, for that, as y equal to x square given, so we can replace dy by 2x dx. So we just replace y by x square. We are going to convert this total integral in terms of x. Why? Because the value of y is given in terms of x. Either you convert this integral in terms of x or in terms of y. Okay, so both are the same thing, you will get the same answer at the end. Okay, but here it is easy to convert the integration in terms of x. Why? Because y is x square. If we try to convert that integral in terms of y, then we should have to take the value of x as root y. Okay, so it may difficult. Okay, so better way, just convert in terms of x. Okay, so therefore, where here in this for in equation 1, we just replace y by x square and dy by 2x dx by taking derivative derivative of y is dy, derivative of x square is 2x into dx. Okay, and also limit of x we want. See here, this is your x and y axis. This is the parabola y equal to x square. joining 0 0 to 1 1. Okay, so now here limits of x, see limits of x are 0 to 1, limits of y are also 0 to 1. Okay, so x runs from 0 to 1. Now with the of this equation 1 becomes 0 to 1 2x plus y square dx plus 3y minus 4x dy. Just replace y square by x square. See, I just replace this y by x square. Okay, bracket square is there. Then after that dx as it is 3x square. Again replace y by x square, and dy is nothing but 2x dx that we have seen. Okay, now merge this all terms, calculate that, we'll get 2x plus x raised to 4. Okay, this is x raised to 4. Now 3x square into 2x is 6x cube. Okay, and 4 into 2 is 8, x into x is 8, x square. Okay, now integrate. Integration of x is x square by 2 as it is. X raised to 4, integration is x raised to 5 upon 5. Integration of x cube is x raised to 4 upon 4 minus 8 as it is, and the integration of x square is x cube upon 3. And we apply the limits. If we apply the limits, so I get 2 upon 2 plus 1 by 5 plus 6 by 4 minus 8 by 3. Okay, so minus for lower limit, the answer is 0. Okay, so just replace x by 1 upper limit. For lower limit it is all the values are 0. Okay, and if we calculate this bracket, we'll get 1 by 30. Okay, so one more thing is here. So see which result we are actually using here. Integration of x raised to n dx. What is the answer of this? Even every time we are using this, it is x raised to n plus 1 divided by n plus 1. Getting this? Okay, so this rule actually we are using to integrate all that things. Okay, now this is the third example actually. Okay, so this is also very simple. So fourth example, find the work done in moving particle by the force field. F bar is given 3x square I plus 2xz minus y j plus zk along the line joining this 0 0 0 to 213. Already we have seen this type of example. We use 2-point form here to find the values of xyz in terms of t here. So same here, work done is equal to F bar dot dr bar. It is f1 dx plus f2 dy plus f3 dz. Substitute the values of f1 f2 f3. This is your f1 f2 and f3. Okay, now using 2-point form joining these two line, this is the line actually joining this is straight line. Okay, so therefore using 2-point form, x upon 2 is equal to y upon 1 equal to z upon 3 is equal to t. So you can use that x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. Same formula to 2-point form to calculate or to find the equation of this line joining these 2 points using 2-point form. So suppose this each ratio is equal to t. So if we take first ratio, x upon 2 is equal to t, what I get, x is equal to 2t. Same here, y equal to t and z is equal to 3t. Okay, so from that, what is dx? Dx is 2 dt, derivative of t is dt, 2 as it is, dy equal to dt and dz is equal to 3 dt. Also same, t runs from 0 to 1, because if I take, see, if x is equal to 0, t is 0. If x is equal to 2, t is 1, because 2 upon 2 is 1. See here, if I take y is equal to 0, because lower limit of y is 0, t is 0, and upper limit of y is 1, therefore t is equal to 1. And same here, so in every value of x y z we get t is equal to 0 to 1. And now put all these values in equation 1. So what I get from 1, 3x square dx plus 2xz minus y dz plus dy plus z dz. So 3 as it is, x is nothing but 2t bracket square, dx is nothing but 2 dt, 2 as it is, x is 2t, z is 3t. Okay, and minus y is t, dy is dt plus z is nothing but 3t and dz is 3 dt. So if we calculate these all things, so what I get, 24t square. See, 2 into 3 is 6, 6 into 4, because 2 square 4, it is what, 24, and t square is there. Okay, now 2 into 2 4, 4 into 3 12, t into t is t square minus t as it is, and 3 into 3 is 90, isn't it? Okay, and just integrate this, it is 36t actually, 36t square, and minus t plus 90 is plus t. Okay, from 0 to 1, and if we integrate this, 36t t cube upon 3 plus 8 t square upon 2 from 0 to 1, and if we apply the limits you will get answer 16. Okay, so in some examples f bar is same, just the conditions are different. Okay, so curves are different joining the different points. Okay, so that is the part of understanding. Once if you understand how to solve, whatever the condition, whatever the curve is given, you can solve the example. Okay, now let us see one more example. Evaluate this line integral where f bar is given 2y plus 3i plus xzj plus yz minus xk along the curve x is equal to 2t square, y equal to t, and z is equal to t cube from t is equal to 0 to 1. Okay, so sometimes same conditions are given but the f bar is different. F bar is same but the conditions are different. Okay, so this is the only change in this type of example. Line integral is f bar dot dr bar f1 dx plus f2 3y plus f3 dz. So put the values of f1, f2, f3. So this is 2y plus 3 xz and yz minus x. Okay, so as x is equal to 2t square, see now we are going to convert this total integral in terms of t. Okay, so therefore x is equal to 2t square, dx is 4t dt, y equal to t, dy equal to dt, z is equal to t cube, dz is 3t square dt. Just take the derivatives and the limits of t are also given 0 to 1. Okay, so t from 0 to, now here from 1, now put all these value in equation number 1. So therefore integration from 0 to 1, 2 into y is t plus 3, dx is 4t dt. Okay, 4t dt. Now x is nothing but 2t square, z is nothing but t cube, dy is dt. Then y is nothing but t, z is nothing but t cube, minus x is nothing but 2t square, dz is 3t square dt. And if we merge all this term, what I get, 8t square plus 12t plus 2t raised to 5 plus 3t raised to 6 minus 6t raised to 4 into dt. Okay, solve this. This is just the uh, calculation. Okay, so give the proper bracket so that you can multiply properly. Okay, and if we take the integration of t square is t cube by 3, integration of t is t square by 2, integration of t raised to 5 is t raised to 6 upon 6, integration of t raised to 6 is t raised to 7 upon 7, minus as it is integration of t raised to 4 is t raised to 5 upon 5. This 8 12 2 3 minus 6 as it is, and just apply the limits. If we apply the limits, just take t is equal to 1 for upper limit and then t is equal to 0 for lower limit. Upper limit minus lower limit. Okay, so 8 by 3, 12 by 2, 2 by 6, 3 by 7, minus 6 by 5, and for lower limit the t is 0, therefore all the values are become 0, and therefore answer is 8.2252285. Okay, so this is the value of line integral for this vector point function f bar along the given curve, isn't it? Okay, so in this way we have solved some examples related with line integral and work done. So also we can solve this example of line integral with the help of another method, and it is Green's theorem. So that we will discuss in next example. Also there are some examples next lecture. Also there are some examples which are depend on the work done. Okay, so for that also we use that concept, Green's theorem, Green's lemma. But for that if you wish to use that Green's theorem, so your curve should be closed. Okay, so that is part of another story. Okay, that we will discuss in the next lecture. Now so for practice, try this example at home. Okay, so evaluate this line integral here. A bar is given joining this curve. Okay, so we have solved this type of examples, so you can solve that at home, practice this examples. Also this is simple line joining, straight line. Okay, so you can use 2 point form here, 0 0 2 3 2. Okay, so thank you. If you like the video, just click the like button, and if you uh, haven't subscribed the channel, just please subscribe so that you can get the update about the next video. Thank you.